Welcome. In this video, we'll learn about quantifying the scope of activities and calculating their durations. And that's part of the process to developing a project plan. So we learned in the previous videos how to understand and have a mental model of the scope of work for a project and how to use WBS to build this mental model in a hierarchical way and matching it to OBS or organization breakdown structure. So in this video, we'll cover the fourth and the fifth step of the project plan development process. So quantity takeoff is the process to identify the quantity or the amount of work for every WBS activity using the relevant units that relevant in terms of matching with the production information that you have from previous projects. So quantity takeoff requires first the scope of the activity. So you need to know you're calculating the quantity for what part of the project or what activity. That's from the WBS. You need to have the project plans and specs as the documents that you can get quantities, and also be careful about quantifying the different materials if they are specified differently in the specs. You need to have very basic geometric understanding and calculation and math, and also calculate the amount of work that is relevant to the activity that you're focusing on. So for example, this wall, it entails masonry work, so I need to calculate it in a volumetric amount. So and also the walls entails painting or finishing on the faces that need to be finished. So you need to calculate the amount of exterior painting here, which is an area quantity. So for the same element in the building, you will have multiple work activities done, and for every one you have the quantity is calculated using the relevant units of measurement. So let's see some examples here. So in buildings, typically before you start digging the excavation, you should remove the topsoil, the organic matter of the soil that you cannot structurally use in the foundation as a replacement soil. And the specs would say topsoil excavation should be carried 5 feet beyond all walls of a depth of 9 inches. So if this is the footprint of the building, and maybe here it shows here some column foundation that carries maybe an elevated or a canopy of the roof. So some people will say I'll just trace the building footprint because this is the foundation, and then I'll see the foundation or the wall foundation or the column foundation of these 3 columns here. But in reality, what will happen is just you have a bulldozer or a blade that comes and take off this whole topsoil of the whole area here. So you're not selective. You can't say just be it's not like a spoon and fork. You're dealing with the whole area here. So the area here will be the whole area, which is 110 times the 70 feet. So this is the area, and then 9 inch is 0.75 feet. So the quantity will end up with is this for topsoil. You can keep it as cubic feet, or typically for soil quantities they are in cubic yards. Another example is the excavation for a basement. So for in basements here, you have to account for first the footprint or the layout of the building or the footings, and then the workspace that's needed around them, because you can just excavate just at the edge of the footing where you want to have the footing at, because how are you going to put the formwork and how you can construct the footing itself if just the soil is at the edge of it. So you want to leave some space so workers can walk and put the formwork, so you can place the concrete after that. So that's around 1, 2, 3 feet. It depends on your judgment here. And then you need also to account for the excavation of the type of soil. And this is why it's important to visit the site and be familiar with the soil conditions. So the slope, the natural slope of the soil, If this is the construction method, if you're not using any support systems for the soil to keep them vertical, then you will leave them for their natural angle of repose for the soil. So you need to kind of know what angle is that, what type, it depends on what type of soil you have. So with this kind of trapezoidal shape, but now in 3D, you will have to calculate an average area. So if you look from the top, the average area of the excavation times the depth, that will give you the volume of the excavation for this basement. If you're dealing with a strip or continuous footing, then the volume of the soil will be equal to the cross section of that excavation, that trench, times the length of the wall. So it will, and that cross section area will equal to the average width, which is in this case here the average of 5 feet 2 inch and 10 feet 6 inch, times the depth, which is here in this case 4 feet. Sorry, topsoil is not counting because that's a different activity. You remove the topsoil in one activity, and then the excavation is another activity. And then the footing length, it depends now on this third dimension here. So that's another example of quantity takeoff. Another example is the backfilling. So that's some tricky to some people here, is calculating the backfill. But the good thing here, you're not calculating it from scratch. You're actually recycling the quantity takeoff you found from the previous activities. So to backfill, you should have done first excavating, so you have this quantity, and then you have the volume of the footing below the backfill level. So the backfill volume will be the difference between how much you took out of the soil and how much you put before the backfill, so how much of that structure you constructed in the excavation void. So that's basically the difference between these is the backfill. Backfill for the basement is similar concept, but you have here to account for the void that the building is creating of this basement here. So the volume of backfill will equal to the excavation volume, this whole trapezoidal 3D thing, minus the building volume, minus the volume of the structure under the ground level. So quantity takeoff is a very critical task, very tedious to some people, that it's very, if they're not detail oriented. But regardless, if I pay a lot of attention to my quantity takeoff, at the end I should expect some errors to happen. And if I calculate, you calculate, the difference should not be like huge, but acceptable range would be like 2 to 5%. And this error comes from many sources. So arithmetic errors in adding or deleting, but acceptable errors. It's not like you're making major mistake here. So you're trying as much to avoid arithmetic error. You're trying to avoid transposition, so dealing with dimensions and changing from one dimension system to another. Omissions, so significant figures. Scaling drawings, that's in the old days. Now we have digital systems to deal with that, but still you will be amazed by how in, like, let's say Bluebeam or on-screen takeoff or any software for quantity takeoff, when you set up the scale, quantities can be completely different, factors of 10, 12. So you have to be careful scaling your drawings. Make sure you scale to the correct ratio. And then unrealistic waste factors. So part of quantity takeoff is to assume waste factors. Sometimes it's too little or too much. When you estimate now, once you have the quantity takeoff, the amount, so the amount of work for every activity, the next will be estimating the durations of activities. So here, the rules for doing that, first you have to do activity by activity. So you cannot just think in parallel to activities. You did this step in the WBS and the scope definition. Now you're focusing on activity by activity. Use consistent time units. So don't estimate one activity by an hour and the other one by days or weeks. Be consistent. Usually it's by days. If you end up with 0.1 day, it's a decision you have to make. You can round it up to a day to have the minimal 1 day in your schedule, or you can add it to another activity, and when they add up, they will add up to a day. So instead of wasting 0.9 and 0.8 days embedded in 1 day duration. Also assume normal level of resources. So don't overstaff your site. Don't think I'm going to use 10 cranes. Assume a relaxed, method of construction, and also assume normal work hours, no overtime. Just use the regular time, and put the project completion date out of your mind for now. So just think about relaxed way of constructing that. Unless there is a constraint, clear constraint that is applied directly on this activity. So for example, in roadway construction, asphalt placement, there is limits on when you can open and close the road. So there are constraints. You have to finish that within a shift. So in that case, yes, but generally, when you estimate the duration of an activity, just remove all constraints that you have initially, and then when you have the schedule network like we'll see, you can put these constraints back and accelerate things the way you want. When you estimate the duration of activity, you can do it in two ways. First, you can do it by expertise you have. So you put just, that will take a week, that will take 2 weeks, that will take 5 days. That's by experience. Over time, you will gain that skill. Or you will use productivity, so production rates. So productivity is basically the ratio between the output of an activity and its input. So it's the ratio between these two quantities. So what's an input into a construction activity is typically time. What's the output is the amount of work. So it's measured in the units that you use to have to calculate the quantity takeoff. So for example here, the input is the required hours for this excavator to dig. So if we observe it in half an hour, it did dig or excavate 154 cubic yards. So the ratio between these will be the productivity of 308 cubic yards per hour. Another thing, the flip of the coin. So the other side of the coin, you can say. So productivity is output over input. Some people in industry are more comfortable talking the unit rate language instead of production rate language. So unit rate is input over output. So they think about how many labor hours to put in producing 1 cubic yards of work. So regardless, you have to, which side of the coin to use, you have to relate that to the performance you're looking for. Performance is the same. So if you want to increase the performance, this means you want to increase your production rate, or in other words, you want to decrease your unit rate. So it's the same, again, it's the same coin, but you're just looking at it from two sides. So for us here, for planning, generally GCs deal with production rates, not unit rates. So we're dealing with productivity, quantity or output over input. Using that productivity rate to calculate duration, so duration is equal to quantity over the production rate, or ideal productivity, times efficiency. An efficiency factor here is a factor that's used to account for different waste causes that you expect on site. And we'll cover these in a minute. So as an example here, you have a pending activity of amount of work 5,000 square feet. Your productivity of the crew or the laborers that you're going to use is this 1,250 square feet per day. This is ideal without considering any issues, but if you consider issues, you expect that they will not achieve this ideal, they will achieve only 80% of it. So when you use the formula that's shown, you will end up with 5 days of work to finish this painting job. Now, how they figure out this efficiency factor? So there are different factors to think about to come up with this efficiency value here. So the first example of factors is space. So space congestion. Generally, when you say if I use one crew, then I will end up with X productivity. If I use 2 crews, I will end up with 2x productivity. That's true until some point where the space doesn't allow to add more resources or more crews. And at this point, actually, productivity goes down. And just this is from a study here that takes around 320 square feet per labor to have an optimal productivity for that labor. There is another factor called learning curve. So the longer you're working on an activity, the less time it will take you per unit. So you're learning to do it faster. But when your work is interrupted, you're starting the learning curve from a higher point. So this is why if you think about doing like paving, just in one shot for the whole road, it will have a better productivity overall, better than doing the pavement in segments and then being interrupted by some kind of work in between. So learning curve is something that's qualitatively you need to think about and reflected into the efficiency factor you have. Weather is another critical factor. So activities of different types are affected by weather in different ways. Weather here meaning temperature and humidity. So this graph here is from another study showing the temperature on the horizontal axis and the productivity here as a factor. So 30% factor to 100% factor meaning ideal productivity. And it shows here different curves for different trades. So electricians, light work, there's bricklayers, and then there are here equipment tasks like equipment operators, and then there are manual tasks. And you can see here that electricians, they kind of can work in a large spectrum of temperatures under different humidity. Humidity is not that big impact for them. Versus bricklayers can only work in limited spectrum of temperature, which is between 40 Fahrenheit to around 100 Fahrenheit, and humidity here, the higher the humidity, and also kind of we need to pay attention to there is an optimal humidity. So too much humidity is bad, and also too low humidity is bad. So optimal humidity is generally like 0.6 here in this case. But why is the difference? Why is the difference between electricians and bricklayers? You think about it, what environment or weather they are exposed to. So electricians' light work, typically there is electrician heavy work, which is they're laying down the utility lines in the site. That's outside, that's outdoor. Versus light work is usually indoor. So indoor, they're not impacted that much by the weather. Versus bricklayers. Bricklayers usually it's outdoor work, so they are affected heavily by weather. So when you look at the graph here, you'll get more information about which trades are affected by weather. If you calculate an activity for an outdoor activity, then weather is a critical factor. For indoor activities, then your efficiency factor is not reflecting that much of the weather. The last factor we'll cover here is overtime policy. So if you decide to use overtime, either like 50 hours per week, so the normal hours per week is 40, 5 days, 8 hours a day. You can extend it 10 hours a week or 60 hours a week. You can see here over weeks your workers experience fatigue. So at the beginning, the first week here, they experience a shock. Like right away, I'm working 10 hours more extra. So you will drop from 100% efficiency to around 83 efficiency. And then you get used to it for the second, third week. And then if you continue doing that, you will feel a big drop or a continuous drop of efficiency here. Of course, 60 hours is more severe than 50 hours. You're working here 50% more than you should. So overtime policy is critical. Yes, you're getting more hours squeezed within a week, but your productivity per hour is dropping. So it's a trade-off here. So that's it for this video. We'll learn about how to focus on activity by activity, calculating the quantity for it, so quantity takeoff, and then using the amount of work that you calculate from quantity takeoff to calculate the duration of the activity. Hope you enjoyed that video. I will see you in future videos, and take care.